Hello everyone, today we're going to talk about the element sulfur. Sulfur is element number 16 on the periodic table. It consists of various things that we use every day. We use it to make sulfuric acid, which consists of the element hydrogen, sulfur, and oxygen, which we previously talked about. We talked about hydrogen and oxygen before. If you want to check out those videos, the link is in the description below. We will talk about various metals that bond with sulfur and how it interacts with oxygen, and it's similar to nitrogen and carbon in various ways in the way that it bonds with other elements on the periodic table. So let's begin. So here's the general overview of sulfur. Let's zoom in and talk about the minute details about the element. So sulfur, here it's from the periodic table of elements app. I recommend downloading it if you're following along with this channel. Then this app on the App Store is a handy guide and a tool for you to use as a reference that shows live pictures and displays that allows you to learn the periodic table more easily than if it was just on a piece of paper. So sulfur exists on your wall as a compound known as gypsum. It exists in nature as crystals, and you can see photos of it online. They're huge next to an individual. We don't use gypsum how it's found in nature as crystals, rather we manufacture it in specific ways that we recognize as drywall, which is the material in between your wall that gives it texture and structure. If you are in a building right now, you can feel around your house, and if you have drywall, then that is a compound that is made of three elements: calcium, sulfur, and oxygen, specifically SO4, so calcium sulfate. Calcium sulfate is essentially rusty calcium because sulfur and oxygen are oxidizers on their own, and calcium is a metal, so sulfur and oxygen both combine to oxidize the element calcium. Sulfur is used to refine things like oil and coal when processing ores. Sulfur is also processed and mined similar to the things that it refines. Sulfur can be mined as well or extracted near volcanoes because they're ejected from volcanic fumes. Sulfur is used in the manufacture of gunpowder. It's one of the three components that are used to create the entire molecule. So it consists of saltpeter, charcoal, and sulfur. Sulfur is the yellow container right here. The darkish container right here is coal, and the white powder here is potassium nitrate. All three create an explosive mixture known as gunpowder, which simply release the nitrogen, the oxygen, and the hydrogen from its bonds, creating gases that expand very quickly, and if they're in a compressed space, they release a lot of energy and expand whatever they're within, and that's what causes the massive energy blast. Quick warning and hazard and responsibility issue. Understand that chemistry is very dangerous, very hazardous, and if you're dealing with things such as gunpowder, treat it with respect and care and understand how it affects you and others. So always relate these elements to you and others, not just now but in the long term, because as we will eventually find out, other elements can linger on, causing residual effects even in the later years, especially if they're radioactive. If you ever wondered why when you light a match in a room, it starts to smell that match smell afterwards, it's because there's a little bit of sulfur within that match, within that phosphorus compound that combines with the air around it, creating sulfur and oxygen. With the heat of the match, it gains enough energy to become sulfur dioxide, and it becomes sulfur trioxide sometimes. As a result, that is the burning smell that we sense in the room. That's why when there's a foul odor in the room, if you light a match, you can use that kind of to extinguish or diminish the previous smell that was unpleasant. The fact that sulfur is also so potent in terms of exploding, even without the other combinations of elements that it mixes with to create gunpowder, it can still create a bright energetic light when you light it on fire, and that property on its own is enough to include it in things such as fireworks, which light up the night sky and create different colors with different types of metals, as we will discuss in other videos. It's important to consume sulfur because sulfur is a key component in three specific types of amino acids in the body body. Amino acids are simply individual components of a protein molecule, which combine in different ways and variations to create various types of proteins that perform different functions in the body that keep us alive and well. So the three amino acids that sulfur is a component of are cysteine, cysteine, and methionine. If I didn't pronounce them correctly, I apologize. But in order to get these sulfur atoms within your body, in order for these amino acids to be formed, you need to consume things such as nuts, chicken, whole grains, green vegetables, eggs, lean meats, legumes, turkey, and various other foods not mentioned that also contain the element sulfur. So zooming in, we have the overall details of what foods contain sulfur that are essential for the body. Rubber is extracted from Thailand, Indonesia, and Malaysia, and that extracted rubber is acquired from trees, and it's collected and eventually through a process known as vulcanization, which involves sulfur. It's made into the familiar rubbery material that we use for various things. Here I have an image of tires which contain rubber, which make contact on the road that grip the surface that your vehicle and you drive on and allow you to safely maneuver throughout the street without slipping in hazardous situations or locations at times where it would be unfortunate to do so. Rubber performs various functions in our society that we wouldn't be able to live without in today's world, and sulfur is at the forefront of its generation. Apart from being utilized to vulcanize rubber, it's also used as an insecticide or as a fungicide to prevent the growth of things on the things that we consume or feed to the livestock that then we either consume or derive benefit from. Since we are talking about chemistry, we also will include the elements that rubber is made of, which are carbon and hydrogen. Two videos that I previously created to discuss the elements in detail. You can view the links in the description below if you're interested in learning more in depth on hydrogen and carbon, which consist of the rubber molecules that we create with sulfur. Sulfur has various allotropes like carbon. An allotrope is simply a different version of the same element. It's like an isotope, only instead of being a different version of the same atom, it's the same atom but in a different molecular structure that gives it different net molecular properties in the macro scale. It's the second one after carbon. Carbon creates various different allotropes, such as the famous ones that we talked about in the carbon video, diamond and graphite, which are both the elements carbon, but since they're molecularly different in structure, they perform differently and exhibit different properties. Diamond being shiny and very refractive and reflective, and graphite being the opposite, dark, light absorbent, and the semiconductor of electricity and heat. So the element sulfur has various properties and compositions. Here we zoom in to group number 6. We see that sulfur belongs to group 6. Group 6 elements include the nonmetal oxygen and sulfur, the semi-metals, properties of both metals and nonmetals, selenium, tellurium, and the metal polonium, and the artificial element livermorium. This group is also called the oxygen group. Both nonmetals react with metals to form ionic compounds, which is why sulfur reacts with both oxygen and other types of metals that it binds to in molecular bonds. Sulfur is one of those rare elements that is different in color. It's yellow like gold, which is why when it combines with iron, it forms a compound known as pyrite, which is fool's gold, which looks like gold, but is neither as valuable or as desired as the element gold, but it still looks like gold. So just like with boron and how we went over its future elements, we're going to go over the future elements of oxygen, which is sulfur, selenium, and tellurium. So we previously talked about the element oxygen. Oxygen is presented here. It says in the description that pure oxygen is silver blue when electrified. Pure sulfur is a fine yellow powder, but when you burn it, it produces a nice blue color. Pure selenium is shiny and gray. It's lustrous and shiny, accurately fitting the description of a general metal. And pure tellurium is shiny and silver white. It's kind of more granule or chunky, but it still maintains a relative shape. The physical properties of most elements in group 6 are solids at room temperature except oxygen, which is a gas. Polonium and livermorium exist as tiny trace amounts and are not pictured here. here. So again, the last element in group number 6 is so radioactive, livermorium, that it's not even presented. But if it were, again, like in the boron video, we would see the element with its full protons, neutrons, and electrons, and its configurations and relative proportions and size. Moving on to sulfur allotropes, again, as previously mentioned in other videos. An allotrope is simply a different molecular composition of the same type of element, like previously mentioned with carbon. Carbon forms various types of allotropes due to the nature of its atomic structure and how it bonds not only with other elements on the periodic table, but also with itself. The different ways that it bonds with itself creates different combinations and structures that perform in different ways and manifest different properties and shapes in the macro scale that we use for different things and that we see as different things, such as differences in color, differences in temperature, differences in viscosity, which is how fast or how slow the liquid element flows on a surface. And all of those differences are created by the differences in molecular structures that the individual sulfur atoms design to combine into. Some of them have more and some of them have less, depending on how many more or how many less sulfurs are added or subtracted to the net molecular structure. That creates differences in properties again of the net structure that is created. And the only other element that has as many allotropes as sulfur is carbon, which has a little bit more than sulfur. So as many of you have known, either through the media or TV or shows or through real life experience in the kitchen, cutting up an onion is not necessarily a pleasant experience when it comes to your eyes. It irritates your eyes because of the chemicals and the sulfur within those molecules. Again, sulfur forms various molecules like carbon and oxygen, and those molecules, when they break down, reform and recombine, and in the process of recombination, they interact with the enzymes and the chemicals that pre-exist within your body, in this case your eyes, and they irritate them, causing them to release irritant tears, which are a special type of tear in your eyes. There's 3 types of tears: irritant tears, basal tears, and emotional tears. Emotional tears are for when you're crying, trying to release stress hormones. You actually release hormones in the process. Irritant tears are in the case of sulfur or other compounds entering your eyes. And the last one, basal tears, are just the standard liquid lubricant that your eyes need at all times in order to stay functioning and working, because if your eyes dry up too much, they won't be able to function and you won't be able to see, losing your vision in the process. The irritant tears come out as a result of the sulfur molecules and compounds that interact with your eyes, and as a result, the irritant tears that are secreted from your eyes counteract the sulfur compounds that enter and prevent you from permanently being damaged by the sulfur compounds when you cut onions. Here's just a diagram and a drawing. So as onions are sliced, they release a class of enzyme alanase, which break down amino acid sulfoxides. A specific compound produced during this process is 1-propene sulfenic acid, which is rearranged by another enzyme called la crematory factory synthase to produce sympropanediol S oxide. Production of this gas peaks 30 seconds after mechanical damage to the onion, and it stimulates sensory neurons in the eyes, causing a stinging sensation. The eye therefore produces tears to flush it out. I recreated the molecule, and here is the 1-propene sulfenic acid. If it's incorrect, then feel free in the comments to correct it and let me know, because I drew this out manually. And here is Allison, and I recreated the drawing so that it easily shows the elements that we're talking about, because again, what's the point of having a molecule drawn out if we don't know what elements are within it? Organic chemists like to simplify molecules and present them in ways that are less complex when visually presented, but at the end of the day, if you don't know how to decipher the individual elements within the molecule, then the whole diagram is useless. And if you can't communicate that information to the general public, then it's only useful to the people that know, and that's why it's important to be able to break these down and draw them out so that anybody can understand what molecule they're looking at. So I drew them all out. I drew out the carbons, the bonds and the sulfur elements that are included within the molecule. And this is the other onion odor and thiosulfates. Thiosulfates are the primary flavor and odor producing molecules in an onion. These compounds are not present in intact bulbs, which means that if an onion grows in soil that does not have sulfur or compounds that change its molecular structure as it's growing and developing, it will not produce these sulfuric compounds that irritate the eyes when cut, which is why some onions don't affect you as much. These compounds are not present in intact bulbs, but are formed via enzymatic reactions from sulfur amino acids. Allicin is one of these compounds, which in turn breaks down to form other sulfur-containing compounds, and here is the molecule of sulfur, S and O. R just means that it can either be carbon or a hydrogen. R is just a placeholder like an X value in algebra for chemistry. Sulfur, when it's molten or when it's burning, like oxygen, it produces blue energy, blue light, and it looks blue when it's ejecting and it's molten from a volcano because it's burning and it's sulfur. If you have powdered sulfur, you can still recombine those crystals together by burning it. Only metals are usually known for recrystallizing in that way and reforming. So acid rain is produced through sulfur dioxide, which is a combination of sulfur and oxygen. Sulfur combined with oxygen to form a gaseous compound in the air, which is poisonous and harmful to living things, including us. Acid rain is produced when things such as sulfuric acid are made. Sulfuric acid is made by taking sulfur dioxide and continuously adding oxygen to it until it's so concentrated with oxygen that it's a strong acid. And again, as we mentioned in the oxygen video, oxygen creates acid, and the definition of oxygen means acid forming. So again, by continuously adding water and pressurizing the sulfur with continuous amounts of oxygen, we create a stronger and stronger acid to the point of generating the acid that we know as H2SO4, which consists of 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms, which we had to add in order to oxygenate and acidify the net molecule sulfuric acid. So a derivative of that compound has been used since the early ancient Greek times in the tale of Odysseus, written by Homer. He uses sulfur dioxide to fumigate a room full of his wife's suitors in Greek mythology, and sulfur dioxide again is poisonous, so it eliminated his wife's suitors in the tale. Sulfur has not only been used since the earliest of days, but has also been included in stories since the earliest of days, which we still read today. Sulfur was used as early as 1600 before the Common Era by Egyptians. They used it for bleaching cotton and getting it the right color that they wanted to. So again, sulfur dioxide is just a combination of sulfur combined with 2 atoms of oxygen. The way that I like to see sulfur is just a heavier version of oxygen. It possesses similar properties to oxygen because it's in the same group, but it's a solid because it's more dense and more clumped up together, so it can't fly off as easily in the air as oxygen. But when oxygen is bound to sulfur, it's able to lift it up and give it wings in order to fly in a similar way that carbon is lifted up by oxygen in the form of carbon dioxide when the oxygen binds to the carbon and flies in the air as carbon dioxide, previously being unable to fly off into the air with just its carbon-carbon bonds. And in the similar way that carbon flies off with oxygen, sulfur flies off with oxygen, previously bonded to itself in an allotropic form, just like carbon. So moving back to this description, this is a book I bought about the periodic table of elements. It shows each individual element as a caricature or as a person that has a personality and describes himself, and easily allows any individual to understand and see how elements compare. When they're things, it's harder to contrast and analyze, but when they're people, it's easier to understand how the elements act and behave relative to each other, because we perceive differences more easily when they're formulated amongst people or when they're presented in a way that we recognize, such as with people. And so the sulfur mentions how it produces a foul odor, but it's not the sulfur element on its own that creates the foul odor. It's actually when it combines with the element hydrogen to form hydrogen sulfide that creates that rotten egg smell. In fact, the eggs that we consume are yellow in the yolk because of the sulfur present within it. When that sulfur combines with the hydrogen, either from the water in the air, the water has hydrogen, or from another source within the egg, that hydrogen recombines with the sulfur producing H2S, which is a volatile poisonous gas similar to sulfur dioxide, which smells horrendously to us and to other things. It's also used by skunks to keep other animals and us away. By the way, I will also show you how to eliminate that skunk smell if you are ever in contact with a skunk, unfortunately, and it sprays you all over. Tomato juice is not the solution, by the way. I will give you the solution. Another thing that sulfur claims to be able to do is spontaneously combust with a bright and intense light, which is why it's useful in gunpowder, because that bright light allows the other elements to be able to be liberated from their bonds and expand into their gaseous forms from their previous solid forms and release a lot of energy in a short amount of time. One final thing that we'll cover before discussing how to eliminate the skunk odor is how sulfuric acid was created back in the day. Before we discuss its specific compounds, we'll discuss how people viewed it back then when they didn't know the specific elements or the specific combination of molecules that produce other molecules in the process. So the green vitriol and the heat produces oil of vitriol. Before, people didn't know what this was. It could have been anything to them, and we'll actually think about it. In your perspective, what does this look like? It just looks like a greenish powder. It can be anything out of anything in the periodic table. And the fact that elements don't just exist in their pure form and can combine in not just one but more than two ways, it becomes very difficult for an individual or modern human to just be able to pick out each individual element that exists within each compound back then. Over time, we were able to decipher what every element and molecule consisted of, and this very same compound became something that we were able to decipher very easily. So that powder that we discussed before is actually iron sulfate. The reason that we pointed it out is because this is the sulfur video and sulfur is in this compound. Sulfur is at the center, again saturated by 4 oxygen atoms. This is already a type of acid. It's a solid type of acid, but it's bound to a very cold metal that takes away its energy. So its net energetic state like this doesn't really affect you that much, but when you exchange it for a more energetic type of metal that's not as cold in terms of energy and give it to a metal that's more energetic by nature, which is hydrogen, you create a compound that is more energetic without the addition of any heat. An acid is just a metal that is extremely hot at room temperature and can reform other atoms without having to add any extra heat to it because it's already made of a hot metal with a lot of energy to transfer to other elements or molecules in the environment. So we exchange the iron bond with the hydrogen bonds. The iron is no longer bonded. The iron gets bonded with the oxygen from the water. So the hydrogen metal in the water now gets the opportunity to bind with the sulfate that the iron was previously bound to. So they exchange chairs, they exchange partners. This is called a double replacement. And as a result, the double replacement creates new molecules known as sulfuric acid and iron oxide. Again, sulfuric acid is one of the things that we use to create various other things such as nitric acid and hydrochloric acid, which we previously discussed in the nitrogen and chlorine video. Without sulfuric acid, we can't make various other acids because it's kind of like a primary acid that's used to make various other things in the world. So the iron gets oxidized, it's relatively more stable, and the sulfuric acid is just the water being oxidized by the sulfate gaining energy in the process, becoming a higher energy form of liquid. Previously just being water with a pH of 7, now having a pH lower than 7. So here's a general chemical formula. Fe combines with water's previous oxygen, and the sulfate combines with the hydrogen's previous oxygen. They recombine and reform. The iron goes with the hydrogen's oxygen, and the sulfate goes with the oxygen's hydrogen. They recombine, and that's essentially how most chemical reactions work. It's basically just molecules trading their pre-existing bonds and forming new types of energy levels that are stable in their perspective. In case you needed a summary, the oxidized iron, its oxides being both sulfur and oxygen, exchanges its oxide with water, losing its sulfate ion SO4 with hydrogen metal's exclusive oxygen atom, keeping it oxidized. The net result is iron loses SO4 but gets oxygen back, becoming rust, and the hydrogen metal in H2O gets oxidized by a new ion SO4, becoming H2SO4 or sulfuric acid, which produces acid rain that we constantly make attempts to prevent. So as a general overview, sulfur is associated with hell and brimstone. Since ancient times it was associated with hell, and since the majority of sulfur derives from deep within the earth rather than the top lithosphere, it only makes sense that our ancient ancestors would label it as an element from such a place. A molecular compound known as galena is a fusion of two elements on the periodic table, lead and sulfur. In this video we're talking about the element sulfur. In another video we will eventually talk about the element lead. When lead and sulfur fuse together, they create the mineral galena. Be careful holding galena because it might still have traces of pure lead, and lead is toxic to the body because it's relatively heavy. It's a heavy metal, and heavy metals are toxic. As you can see, lead is number 82 and sulfur is number 16 on the periodic table, which indicates its amount of net energy. And the higher an element is on the periodic table, the more net energy each individual atom has and possesses, and can inflict upon the human body and cause various diseases such as cancers and other genetic mutations that one would rather not experience. Another type of molecular compound that exists with the element sulfur is known as blende or zinc sulfide, which is a lustrous looking material resembling zinc in its pure elemental form. Combined with sulfur, it produces a rocky-like texture, which up close looks just like any other common rock that you might find in the mountains. Sulfur forms deep under the Earth's crust, and if there's any elements other than sulfur present, they combine with it to form these various minerals that we're discussing. Usually sulfur just likes to combine with itself. It's one of those elements that can be found in nature on its own, but if it has to interact with other elements in its vicinity, then it will gladly look for ways to bind with them and form lower, more stable energy levels molecularly. So a quick detour from the minerals, we're going to talk about how to eliminate the skunk smell from either yourself or your pets or wherever it is you want to remove it from. So a skunk produces its odors using the element sulfur in its compounds. Regardless of what compounds it produces, at the end of the day, it includes sulfur within the molecules. So we need to eliminate those molecules. Specifically, we need to get that sulfur out of the compounds that it's in. So the three products that you'll use in order to remove the skunk smell are baking soda, which is sodium bicarbonate. Its molecular formula is NaHCO3. The second item is 1 teaspoon of shampoo, preferably baby shampoo, because it's lighter and it's easier on the skin. Finally, the third product to combine it with is hydrogen peroxide. Hydrogen peroxide's molecular formula is H2O2, similar to water, except it has one more oxygen. An interesting fact about hydrogen peroxide is that it was difficult to identify its molecular formula because of its reactivity and natural instability. It decomposes very quickly into water and oxygen. In fact, here's a molecular formula for its decomposition. Hydrogen peroxide decomposes into the element oxygen and water. That's not balanced. Before you use that equation, make sure to balance it. So there you go. We have a quick overview of what is needed in case you get sprayed by a skunk. These are the chemicals that you use to remove it. You may notice that the shampoo has two types of molecules known as sodium lauryl sulfate and sodium lauryl sulfate, and they both have the word sulfate in them, which indicates that there's sulfur compounds within the molecules itself. So you use sulfur compounds to get rid of other sulfur compounds. Another mineral formed in the Earth's crust that contains sulfur is known as calcopyrite. Calcopyrite contains the elements copper and iron apart from the element sulfur. According to this article, calcopyrite is a brass yellow mineral with a chemical composition of CuFeS2. It occurs in most sulfide mineral deposits throughout the world and has been the most important ore of copper for thousands of years. The surface of calcopyrite loses its metallic luster and brass yellow upon weathering, which is similar to the way that iron rusts, and it makes sense because iron is in this compound. So that is the molecular formula for calcopyrite. Moving on to the next mineral that contains sulfur in nature, gypsum. Again, gypsum gypsum. Calcium sulfate is the organic compound with the formula CaSO4 and relates to hydrates. In the form of gamma anhydrite, the anhydrous form, it is used as a desiccant. One particular hydrate is better known as plaster of Paris and occurs naturally in the mineral gypsum. Again, as previously mentioned, it can be found in caves in Mexico or around the Gulf. Here is a version of how it looks like, and here is calcium, sulfur, and oxygen. That's the three elements that it's made of. And here is a description. Calcium sulfate is the organic compound. It's again used in drywall and other various things. The final mineral that we're going to discuss in this video that includes sulfur is barite. Barite is a mineral composed of barium sulfate. Its mineral formula is BaSO4. Again, you'll notice that SO4 is common with sulfur and oxygen. It's used in sulfuric acid, H2SO4. If something to remember about sulfates is that it's always SO4, which indicates that the sulfur is bound to 4 other oxygens, and then whatever other metal it's bound to is just a compound and fuses to that, and as a whole it produces a new type of either liquid in the case of sulfuric acid or gas, and in the case of these minerals it's just a metallic version of the sulfur compound, and all of those things are related with the sulfate molecule itself. So the molecular formula for barite is BaSO4. So wrapping up this journey with sulfur and all of its properties, we're going to conclude with rubber and its vulcanization and how it looks as a molecular formula when it's combined with sulfur to make it that elastic type of carbon-hydrogen sulfur molecular bond that we know as rubber. So this is vulcanized rubber. This is how it looks like molecularly. As you can see, the sulfur is binding 2 different molecules of carbon and hydrogen together. These are unsaturated bonds and these are saturated bonds. So rubber is a fusion of unsaturated carbon bonds with saturated carbon bonds and hydrogen bonds all fused together to create that net molecule with its net properties. So the next time you hold a rubber ball or you bounce something on the floor or you drive your car, just know that rubber consists of this type of molecule. Here's another diagram that shows vulcanized rubber. Vulcanized rubber comes in various forms. Cross-linked vulcanized rubber can be made so hard by adding more sulfur cross-links that it feels like solid plastic. Not at all like what you ordinarily think of as rubber. So if you ever interacted with those rubber concrete type floors, like on a playground or some other environment, it still feels soft like rubber, but it feels almost as hard as cement because they add so much sulfur to the bonds right here that they start to become so adhered to each other that they change properties at the macro scale, becoming relatively harder than softer rubbers that have less sulfur. Ebonite, which is what this electrical insulator and clarinet bell are made of, can be as much as 30% sulfur. Natural latex rubber, as it comes from this plant, purified of course, is widely used in medical and scientific applications. This latex tubing is more stretchy than pretty much any synthetic alternative. In the laboratory, especially as scientists, we interact with various items that have rubber, especially if we're dealing with things like Bunsen burners when we're connecting the gas or when we're dealing with vacuum tubes and pressures. Rubber really creates an airtight seal that is useful for such things that require certain pressures and conditions. So that was sulfur explained in 38 minutes or less. If you're interested in watching the previous video, it was on boron explained in 28 minutes or less. If you like this video, please make sure to like, comment, and subscribe, and share it to your friends in case they're interested in chemistry as well, or they're just interested in learning the general aspects of chemistry and the periodic table in general. I will talk about more elements to come. The next video is on krypton, so stay tuned for that. Other than that, thank you guys for watching. Have a great time. Have a great day. Have a great life.